Good morning. And in this topic here now is where you will be putting everything to use. Equations where the unknown quantities is in index form. So this is where you will be working with problems, okay? And let's just state some facts right away. If a to the m is equals to a to the n, and let me expand this out a little bit. Is it much clearly? A variable, a base to a letter equals a base to a different letter. That means that these two values must be the same, and these two values must be the same because these are both a's. Therefore m and n must be equal. Therefore m must be equal to n since they have or are equal. In other words, you can put that on that way. Okay, let me shrink number again. You can fit on the screen. So what this means is that if these two bases are the same and we have an equal sign here, that means that whatever is on this side is on this side. Imagine a mirror. You put a mirror on this side. Whatever you see on this side on the mirror must be what is in front of the mirror, and what is inside of the mirror must be what is outside also. Okay, so then here we'll be putting everything what we have seen the laws of indices to use to practical. Okay, so let's start with a problem first of all. So we're going to find the solution. A problem has been given to you as 64 to the power of x equals 16. How can we solve such a problem? Okay, that problem should not take us any kind of stressing. All right, so the way you're going to be approaching this is to change both sides to the same base, because if you notice on the concept here, it says that so long as both of them have the same base and they're equal, that means that whatever is on top must be equal what is also on the top. So the only way we can get 64 to look to something that is familiar with 16 to make it have something that is familiar with 64 is to change them to the same base. Now, what that base will it be? Well, this is the way you're going to be doing it. Always divide by prime numbers. Prime numbers, and these are prime numbers. So we're going to be using these numbers to start off with. What are prime numbers? Prime numbers are numbers divisible by 1 and itself. Those are the only factors of any prime number. The first set of prime number is 2, 3, 5, 7, 11, 13, 17, 19, etc., etc., etc. Okay, so those are prime numbers that are only divisible by 1 and itself. So that is the only factor for the prime numbers. So we will get 64 to look to a base to one of these, as well as 16. Okay, so the way you're going to be doing that is that you are going to take 64 here and start dividing 64 by the first prime number that can go evenly into 64. What's the first prime number that can go evenly into 64? 2. So take 2 into 64, that gives us 32. 2 into 32, that gives us 16. 2 into 16, that gives us 8. 2 into 8, that gives us 4. 2 into 4, that gives us 2. And 2 into 2, that gives us 1. Therefore, 64 could be written as how much? 1, 2, 3, 4, 5, 6. So 64, we can say now that 64 is actually 2 to the 1, 2, 3, 4, 5, 6 to the 6th power. That's 64. Okay, now we go to 16. Let's convert 16 to a base 2. We divide by the first base, which is 2. 2 into 16, 8. 2 into 8, 4. 2 into 4, 2, and 2 into 2, 1. So you have 1, 2, 3, 4. So 16 is actually 2 to the 4th. So this is what you're going to do now. So you're telling me now that 64 is equals to 2 to the 6th power. So wherever you see 64 here, you will write 2 to the 6th power. So let's do that. 2 to the 6th power. No, that is 6, the value of 64. But what does the 64 has? It has an x outside. So you put your bracket outside. X equals, now 16 is actually 2 to the fourth. So you put 2 to the fourth. Now, what does this look like? Doesn't that look like the rule that says a base to a power to a next power? What should we do? Well, we keep the base and we multiply the powers. That's what we do. Okay, so that's one of our laws of indices. So we're going to take now 2 and 6 times x will give us 6x equals 2 to the fourth power. Now, if 2 is equals to 2 and they're joined by the equal sign, then this is telling me that 6x must be equals to 4. So what's the value of mx? Well, you bring this piece here. Let me write that down. Let me do that in black pen. You will bring the top piece since both of them have the same base. Since both has same base, okay, you're gonna bring down the top piece, which is 6x equals 4. Now this is an algebraic expression where you can solve for the x. This is multiplication equals 4. So this is telling me that 6 times a number, a whole number, a fraction, something must give us 4. The way you're going to do this, if this multiplication, the reverse of multiplication is that you divide. By what value are you going to divide? You are going to divide by the coefficient of the variable. What is a coefficient? The value which is in front of the x. So divide by coefficient of variable. Why are we going to divide by the coefficient of the variable? Well, we're going to divide by the coefficient because we want to find the value of the unknown. So we now put 6x over 6 equals 4 over 6. What you do on one side, you must do on the other side if they are equal. Okay, so the 6 here will cancel out, and so we end up with x equals 4 over 6. But we know from maths that so long as the fraction can reduce, we will reduce them. Both of them are divisible by 2. So 2 into 4, 2, 2 into 6, 3. So therefore we're saying that x is actually 2 over 3. So when we take 2/3, our value will be 16. Okay, that's what that problem is telling us now. That whenever we take 2/3 and we put it here, our value will be 16. So we can prove that, okay, by using the laws of indices. So let's just prove that so that we can clarify with that problem. So we're going to take now 64x. This is just to prove it. You don't have to do this piece here, but if you just want to make sure that the answer is correct, this is telling me that when I take 64 and instead of writing x I put 2/3, that means that that's supposed to give me 16. So let's prove it. Well, 64 is actually 2 to the 6, so we put here 2 to the 6 to the 3/4 power. Well, what does the rule say about indices? A base to a power to a next power will keep the base and multiply their powers. So that's what we do. We put 2, 6 times 3/4, 2 into 4, 2, 2 into 6, 3. That gives us now 2 and 9 over 2. Okay? Okay, my mistake. Sorry, I wrote here 3/4. It's supposed to have been 2/3. Just thinking of something else, just not next number. So it's supposed to be 2/3. So let me scratch this out. So therefore, 2 to the 6 times 2 over 3. That gives us now 3 cancel here 2, giving us 2 to the 4th. So what is 2 to the 4th? This is telling me that it's 2 times 2 times 2 times 2, which is 2 times 2, 4 times 2 times 2. 4 times 2, 8 times 2, and 8 times 2, 16. So that's our solution, which balance off with that 16 is actually 64 to the x, where x is actually 2/3. So that proves it that that's our correct answer. Again, you don't have to show me the proof, but if you want to make sure that your answer is correct, you can go ahead and substitute in there. Okay, so for right now, all I want you guys to do is convert them to the same base and then solve for the unknown. Most of the times it's going to be division, addition, subtraction, and multiplication. So, but I am only going to give you questions that are based on the same concept here. I'm not going to ask you a question for something that is addition if I did not show you addition. So since this is multiplication here, I'm going to give you one for assignment which will be on multiplication also. Okay, so you will have to do the same procedures here. So let's go to our next example. We take now, the next problem is to be 625 p minus 2 equals 5, 2 plus p 1. I mean, sorry about that, 1 here. Let me make this p a little bit bigger. Now convert them to the same base. 625 with the power of p minus 2, p and 5 equals 1 plus p at the power. So we're going to take 625 on the side and start dividing by the first prime number that can go into 625. 2 cannot go into 625, 3 cannot go into 625, so therefore only 5 should be able to go in there evenly. So start with 5. 5 into 625, that gives us 1, 2, 5. 5 into 125, 2, 5. 5 into 25, 5. 5 into 5 now, 1. So that's telling me that 625 is actually here you have here, sorry, this should have been 5. Where am I? Okay, so that's 5. So you have 1, 2, 3, 4. So 625 is actually 5 to the 4th power, but all that is to the what power? P minus 2. Okay, which equals now 5, 1 plus p. The rule says now that a base to a power times to the next power will keep the base and multiply the power. So you can recall the rules. So this tells me that 4 times p minus 2. Now some of you may be asking, why is it did I not just multiply 4 times p? Well, what is that is actually to the power. It's not just this information to the p power, it's this whole thing. The p minus 2 is actually the power here. That's the index. So that's one big joint form. So now we're going to take now and say that since 5 is on this side and 5 is on this side, this top value here for p minus 2 bracket is equals to 1 plus p. That's what they are equal, because 5 must be equal to 5 at the bottom. So we take now 4 bracket p minus 2 equals 1 plus p. Apply distributive law. And we expand. 4 times p, 4p. 4 times 2, well, that's a negative 2, that gives us 8, negative 8, 1 plus p. Okay, now we will group like terms. Whenever you are moving values from one side of the equation to the other side, mean then you cross the equal sign, the signs will change on the value. Okay, in short terms, if this is addition and you want to move the addition from this side to this other side, it will become subtraction. So watch what happens here. I bring down the 4p because I'm going to keep my p's here. Since this p, positive p, is coming to the other side, it will become negative p equals. Bring down the 1. Since this negative 8 is going to come to this other side, I make it plus 8. Only for addition and subtraction. For multiplication, it doesn't change sign. Okay, now 4p minus p will give us 3p. 1 plus 8, 9. Now this goes back again to this rule here, which we have here. 6x equals 4. What should we do? We should divide by the coefficient, and so the coefficient here now is the 3. So we will divide both sides by 3. So divide both sides by 3, or what we call the coefficient. So if I use the number 3, don't feel that you will be dividing by 3 every time, but by the coefficient. But I'm just specifying which one is the coefficient. So therefore we end up with 3p over 3 equals 9 over 3, which gives me p equals to 3. And our solution is p is equal to 3. So that's what you're doing. You're solving for it. Okay? Let's go to our next problem. We have here C. 5x, open close bracket, 25 to x plus 1 close bracket equals 625. Now, one of the things you're going to be learning about this part here is that you have been doing the numbers over and over again. We already know that 625 is what base to what power. But from just a problem a while ago, we understood that 625 could be written as 5 to the 4th. So if you notice, these numbers will be keep on repeating a lot. You just have to manipulate it. And 25 is actually 5 squared. So let's start our step. 5x, open close bracket, 25 is 5 squared, but 2x plus 1, close bracket, what's a bigger bracket now, equals 5 to the 4th. This look a little bit confusing. A bracket within our next bracket, a power to a power within brackets and brackets. Don't worry about it. Take piece at a time. Remember, BEDMAS, brackets first. You don't start from the outside bracket. You're going to go to the inside bracket first of all. The inside bracket is this. 5 to the second power and this base, and this power. So this piece here that I'm highlighting here, notice, this is telling me that we will apply this rule. A base to a power to a next power will keep the base and multiply their powers. Okay? And then we come out from there. So we bring down this first one, 5x, close bracket. Keep the base here 5. And then you say 2 times 2x, just as how we did here. We said 4 times p, 4p, so you could go ahead and multiply it up here if you want. So we do that. 2 times 2x, 4x. 2 times positive 1 plus 2, close bracket, equals 5 to the 4th. Now, what's the next rule we will apply? This is telling me a base to a power times that same base to different power. What should we do when we have the same base? Okay, well, we know that there's a rule that says that if there's a base to a power times that same base to different power, we'll keep the base and add their powers. Okay, so we work on this side here. So we put now 5, bring this x, plus the 4x plus the 2. Notice that this 4x plus 2 came from this one, this x came from this one, and that is equals to 5 to the 4th. Now, doesn't this look like, although this is still expanded, like the problems that we had before, that if one side is equal to the next side, then the top values must be equal? Okay, so now we bring down the top values and we put x plus 4x plus 2 equals 4. That's what the problem is telling us. So let me expand this a little bit more. We can zoom in there. All right, so we have now x plus 4x, that gives us 5x plus 2 equals 4. Because this is addition and we want to bring this positive 2 to the next side, then this is what happens. We put 5x equals, bring down this 4, and since it's positive, it becomes minus 2. Okay, so now we have 5x equals 2. So 5x equals 2. Go back again. The rule says that if you have a variable like here, 3p equals 9, you must divide by the coefficient, which is 3. So let me see. Give you 2 seconds to determine what's the coefficient here. If you guess the number 5, you're correct. The coefficient here is 5. So we will divide both sides by 5. So end up with 5x over 5 equals 2 over 5. The 5's will cancel out, giving me that x equals 2/5. Positive 2/5. So at no time I am telling you that the answer must be a whole number. a fraction, and it can also be a negative value. All right, so let's go to our next problem. Now here is where we're going to be applying the rule also. Okay, we're going to be applying, let me bring this next new log here. We're applying the rule that says this was what, problem D. I'll give problem D now, and we have D. 9 to x equals 1 over 81. You can work with this problem two methods. We will apply any method that we want, okay, but you must recognize the problems themselves. So let's convert them to have the same base. We can recall at this point that any base, okay, any base to a negative power is equals to 1 over that base to its positive power. Well, what is the power of this 81? The power of this 81 is actually 1. It's 1 here. That's understood. So any number that is written by a whole number, the power is actually 1. So let's convert it to a negative power. So this is what happens. We have now 9 to x equals 81 to the negative 1. See how that negative 1 came there? Now we have 9 and 81. We are to convert them to like bases. So you take 9 here and you start to get 9 to a base. What's the first prime number that can go into 9? 3. 3 into 9, 3. 3 into 3, 1. So therefore 9 is actually 3 to the second power to the 2x power. Okay? 81 now. Well, you take 81 on this side. You take 81 and convert it to a base 3. 3 give us 27. 3, 9, 3, 3, 3, 1. So 81 is actually 3 to the 4th power. So you put 3 to the 4th power to the negative 1. Okay? Now, what rule applies there now? Well, the rule that applies here is a base to a power to our next power gives us that base, and we multiply their powers. So that's what we will be doing. So you say now 3, 2 times 2x, 4x. Okay, bring on the 3 here. 4 times negative 1. This is not saying 4 minus 1. It is 4 times a negative 1, which gives us a negative 4. The laws of integers. Okay, so you're applying almost everything right now. So you have 3 as the basis. Since 3 are the bases, then this must be that 4x must equal to negative 4. Okay, now what do we do? Well, divide by coefficient. 2 seconds. Think on what is the coefficient. If you guess the number, the whole number 4, then you're correct. The coefficient is 4, positive 4. So we put now 4x over 4 equals negative 4 over 4. So 4 divided by 4, they cancel out. 4 divided by 4 cancel out. So we end up with x equals to negative 1. This is your solution to that. Okay, so that's one method. The other method how you can solve this is that you can convert it to a different base if you want, but that is when you have already recognized their values, meaning that you know what is the value of the bases. Okay, we all know that 9 could be written as, that 81 could be written as a base 9 to the second power. What does that mean? That's simply telling me that 9 times 9 equals 81. And if you notice here, this is already a base 9. So let's do that approach. So the next approach would be, I'm not saying that you have to do this first method. You will decide which method to use. We have 9, 2x equals 1 over 81. 81 is actually 9 squared. Okay, so we put here 9 2x equals 1 over 9 squared. You see that? This rule now says that if we have a base to a negative power, we'll keep the as a fraction that way. So this looks like this now. So we're going to reverse it to a negative power. So this becomes now 9 to x equals, and that becomes 9 to a negative 2. Okay, now 2x equals negative 2 because the bases are equal. Okay, so you put here now 2x equals negative 2, and so divide again by coefficient. We end up with 2x over 2 equals negative 2 over 2, x equals negative 1, and you end up with the same solution as the previous method. So whichever method you want, but this is where you will start to apply the concepts of this. Okay.